Hi, in this lecture let's talk about multiplication of two matrices. Before we proceed, there is a small condition. Multiplication of two matrices is valid if and only if number of columns of first matrix equals the number of rows in second matrix. Sounds confusing. Let's see. We have A as Aij having order of m cross n and B as Bjk having order of n cross p. A cross B is valid if and only if we have n columns in A and n rows in B. So then A into B, let's denote it by C, will be defined as summation from j equals 1 to n A I j B j k. That's it. With this, it's look really confusing, because all those summations are involved and it becomes complicated. Before understanding the meaning of the summation and understanding how we multiply two matrices, let's solve a very basic question. Although it's not really basic, it appeared in GATE 2005, but it's very easy. I know you can do it yourself. So just pause the video and try it out yourself. Or rather, solve along with me. Okay, so we have X as 4 cross 3 matrix, Y as 4 cross 3 matrix and P as 2 cross 3 matrix. And we have to find the order of this huge expression. So whenever these type of problems come, I have a fixed set of steps which I follow. And although it becomes a bit lengthy, but your answer will be 100% correct. So if you're starting it out, I would suggest you follow along. And if you have already experienced with these type of problems, then you can skip. Okay, so we will first write order of all the matrices. So X has the order of 4 cross 3. We need X transpose also. So X transpose will be having the order of 3 cross 4. In the transpose, we just swap rows with columns. So in X we have 4 rows and 3 columns. So X transpose will have 3 columns and 4 rows. Simple. So Y has the order of 4 cross 3. Y transpose will have order of 3 cross 4. And the next and P has the order of 2 cross 3. P transpose will have order of 3 cross 2. Okay, now I will first find X transpose Y. So X transpose Y will be X transpose will have order of 3 cross 4 and Y will have order of 4 cross 3. So see here that number of columns in X transpose equals number of rows in Y. So X transpose Y will have order of 3 cross 3. Now if you find inverse of X transpose Y, it will have the same order as X transpose Y. So this will also have the order of 3 cross 3. Okay, next we'll multiply it with P. So P is having the order 2 cross 3. So P 2 cross 3 is multiplied with X transpose Y inverse, that is 3 cross 3. So 3 and 3 is same, so we will get P X transpose Y whole inverse, and this will have order of 2 cross 3. So 2 and 3. Okay, so whatever is left, just remove all these, and whatever is left you just have to write the order. So 2 and 3. Next, P transpose. So we have to multiply this with P transpose. So P X transpose Y inverse, this is having the order of 2 cross 3, and we have to multiply it with P transpose. So this is having order of 3 cross 2. Okay, so 3 and 3 is same, 2 and 2 are left. So we have P X transpose Y inverse P transpose. So this is having order of 2 cross 2. Now if you find the inverse of this expression, so the order will be same. So 2 cross 2 is the answer. So I'll quickly write here. I have not mentioned options here, but in the exam there was option 2 cross 2. So if you go through with the papers and if you find this problem, you can easily take 2 cross 2 is the answer. Okay, let's solve one more question. So in this I'll explain how to multiply two matrices. We can write a square as a into a. So write a 2 times, 1, 2, minus 1 and 4. And 1, 2, 1, 2, minus 1 and 4. Now follow the step-by-step procedure if you're follow the step-by-step procedure if you're just starting out. Take the first row of first matrix and first column of second matrix and multiply the corresponding elements. So 1 is multiplied with 1, you will get 1 into 1, and 2 is multiplied with minus 1, so 2 into minus 1. Add these two values, so 1 into 1 and 2 into minus 1. Simple. Similarly, now take first row and second column this time. So 1 into 2 plus 2 into 4. Again, now take second row and first column. So you will have minus 1 multiplied with 1 plus 4 multiplied with minus 1. Now take second row and second column. So minus 1 is multiplied with 2 and 4 is multiplied with 4. A while ago we saw one summation. Let me go through it. Yeah, this summation. It means that you have to multiply the corresponding elements and take the summation. So that's what we are doing here. We are multiplying the corresponding elements and taking the summation. Okay, so let me write this matrix. So we have 1 into 1 is 1 plus 2 into minus 1 is minus 2. So 1 minus 2 is minus 1. 1 into 2 is 2 plus 2 into 4 is 8. So 2 plus 8 is 10. Next, minus 1 into 1 is minus 1 plus 4 into minus 1 is minus 4. So minus 1 minus 5. So this is, so minus 1 minus 4, this is minus 5. Next, minus 1 into 2 is minus 2 and 4 into 4 is 16. So minus 2 plus 16. So this is 14. So this is our final answer, A multiplied by B. Let's see one more example. We have A as 1, 2, minus 1, 0, 3, 1, 1, 4, 3 and B as 2, 1 and 2. So A is having dimension of 3 cross 3. B is having dimension of 3 cross 1. So 3 and 3 are matched. So the resultant matrix will be having the order of 3 cross 1. Okay. Follow the steps which I showed you in previous question and solve it yourself. Pause the video and solve patiently step by step. And let me know in comments what is your answer. I have solved this question step by step in lecture notes and the link I have added in the description. You can go and download the lecture notes and compare your answers. Let's see some properties of matrices. So matrix multiplication is not commutative. So if we have two matrices, A as Aij and B as Bjk, if the product AB exists, then it is not necessary that product BA also exists. And even if it exists, it is not necessary that AB is equals to BA. It may or may not be equal, but it is not necessary that BA is equals to AB. Matrix multiplication is associative only if dimensions are ensured. So it means that A into B into C equals AB into C. So this is equal if and only if all the dimensions are compatible for matrix multiplication. Next is distribution property. Matrix multiplication of matrices is distributive over addition. Suppose we have A into B plus C. So we can write it as A into B plus A into C. So this is true. Multiplication is distributive over addition or subtraction maybe. So yeah. Next is, if AB is 0, then it doesn't matter. Then it does not mean that either A or B equals 0. So let me explain this with an example. Suppose we have 1, 1, 1 and 1. So let's call it matrix A. So matrix A is 1, 1, 1 and 1. And matrix B as 1, 1, minus 1 and minus 1. Clearly we see that A is not equals to a null matrix and B is also not equals to a null matrix. But let's multiply AB. Let's find it out AB. So we have 1 into 1, this 1, and 1 into minus 1 is minus 1. So that is 0. 1 into 1 is 1. 1 into minus 1 is minus 1. So 1 minus 1 is 0. Similarly, we have 1 into 1 is 1 and 1 into minus 1 is minus 1. So we have 0. So next 1 into 1 is 1 and 1 into minus 1 is minus 1. So we have 0. See that AB is 0, but neither of A or B is 0. So this property is very important. If AB is a null matrix, then it doesn't matter that A is 0 or B is 0. Okay. If AB is a null matrix, then it doesn't matter that BA is also a null matrix. This is very important. I think we have already covered this, but let's try to see this. We have AB equals 0. So in the last property, we saw that it doesn't matter that A is a null matrix or B is a null matrix. Also, if AB is a null matrix, then it doesn't matter that BA is also a null matrix. In fact, BA may or may not exist. If the dimensions are true, then BA will exist, and if the dimensions are not true, then BA will not exist. Okay. Next is cancellation laws. Suppose we have A, B and C are three matrices, and AB equals CB. Then we can say that A is equals to C. So this is called right cancellation. Next, one more. If we have CA equals CB, then we can write A equals B. So this is called left cancellation. Okay, that's it in the properties of matrices. Just remember, these properties are really important, so just go through it. I have added links to my lecture notes. You can go through it. You can download them and go through it. I have added all these properties with their examples. In the end, let's solve one problem. So we have three matrices, P 4 cross 2, 2 cross 4 and 4 cross 1. And we have to find the minimum multiplication required to compute PQR. So this is a gate problem. It appeared in 2013. So let's try to solve it. So we need to find the multiplication of P, Q and R. So let's find out PQ. So P is 4 cross 2 and Q is 2 cross 4. So let me try to give you a visual explanation. So P is having 4 rows and 2 columns. So 1, 2, 3 and 4. So we have 1 column and 2 column. It can be any matrix, so I am writing it like this. Q is having 2 rows. Q is having 2 rows and 4 columns. Now, if you have to find out PQ, then you will take then you would simply take first row and multiply it with first column. So there will be 2 multiplications. Second row, second column, again 2 multiplication. Third row, third column, again 2 multiplication, and fourth row and fourth column, again 2 multiplication. So the number of multiplication will be 8. Next, let's multiply PQ with R. Let's multiply PQ, which is having a dimension of 4 cross 4 with R. R is having dimension of 4 cross 1. Okay, again let's try to visualize it. So we have PQ as 4 rows and 4 columns. R has 4 rows and 1 column. Okay, so we'll take first row and multiply it with first column. So we will have 4 multiplications. Next, if you take second row and multiply it with first column, again 4 multiplication. Similarly for third row and fourth row, we'll have 4 and 4 multiplications. So 4 plus 4 is 8 and 4 plus 4 is 8. So 8 plus 8 is 16 multiplications. Okay, this is one case. Let's try to solve it for other case and see whether it exists or not. So this time we will multiply QR first. So Q is having a dimension of 2 cross 4 and R is having a dimension of 4 cross 1. Yeah, it exists. So 4 and 4. So QR will be having a dimension of 2 cross 1. Let's count the number of multiplications. Q is having 2 rows and 4 columns. Let's count the number of multiplications. So Q is having 2 rows and 4 columns. R is having 4 rows and 1 column. Okay, so QR will be having first row with first column, so 4 multiplication, second row with first column, again 4. So QR will be having 8 multiplications. Okay, so next now we multiply P with QR. So P is having a dimension of 4 cross 2. QR is having a dimension of 2 cross 1. So 2 and 2. So P, Q and R will have a dimension of 4 cross 1. Let's count the multiplications. So P is 1, 2, 3, 4 and 1 and 2 columns. QR is 2 rows and 1 columns. So let's see the number of multiplications. So we have first row, first column, so 2 multiplications. Second row, first column, again 2 multiplication. Similarly for third and fourth row, we'll be having 2 multiplications. So total 8 multiplications. So let's compare. In case 1, we found out that it took 8 plus 16, that is 24 multiplications. In case 2, we got 8 plus 8, that is 16 multiplications. So yeah, let's revisit the question again. So we are required to find the minimum multiplication required to compute PQR. So the answer will be 16. Just try to solve it. Just try to solve this yourself and check whether you are getting 16 as an answer. 16 was the correct answer. Just try to solve this yourself and see whether you are getting 16 as an answer. Also, I have added links to the lecture. Notes. You can go through it, download them, and use them to understand the concepts clearly. In the next lecture, we will solve some more problems which appeared in GATE exams. So stay tuned.